Awesome. So I just want to point out some things to make sure you guys have it for the PhET. Once I'm done with the notes, you're welcome to keep playing with it. But I want you guys to really understand what's happening in our solar system to get an idea of how everything is behaving together. So the first version is the model version. And when you click start, let's actually have the gravitational forces and also show their paths. So first thing that we're going to have to keep in mind when we're looking at this is we can see that the planet Earth is orbiting the sun. An important factor for this to happen is gravity, because the moment I turn off the gravity, we're going to notice that the Earth is going to go bye-bye. Bye-bye, Earth. See you later. Now you're into space. All right? So that's kind of the first thing that I want to talk about when we're thinking about our notes. I'm going to write on the piece of paper. You're welcome to write on the piece of paper as well or type it up, depending on what you guys kind of need. So let's think about, for example, I have the planet, which is the sun, and it's a massive, massive planet. It interferes with space-time, and I like to think about it like a sheet, like an elastic sheet, and it's a heavy ball, and as the ball is sitting on that sheet, it pulls it downward. So that disrupts space-time, and it will pull certain things into it, like that, but other things it will not. So that's just showing the gravity and how the gravity is disrupting that space-time there. Are we okay with that so far? So here's my sun, and we're just showing how the gravity of the sun can trap things in there. Now, depending on where you are location-wise, it will either trap you in the gravity or it won't trap you in the gravity. So, for example, if an object is all the way out here, it's not going to be trapped into the gravity of the sun, so it's just going to go on its own little merry way. Are we okay with that as an idea? If it is actually close enough to the sun, then it will be trapped in its gravity and it will stay in an orbit around it. Are we okay with that as an idea? So keeping in mind, so when we're playing with that PhET software, if, for example, let's reset this guy. If we make our sun a lot smaller, we can see how that then interacts with the Earth. So you see how as I made it smaller, the gravity's less? Make it larger, the gravity's more. All right? Let's turn it on, see what happens. If I have really large sun, kept my Earth the same size. Play it through. Oh, it does not like that. It does not like that. And it crashes. Oh, not yet. Maybe not. Let's see. It might eventually crash. Oh, that's an interesting orbit that it's taking. It's elliptical instead of a circle, which it should be. All right. Yeah, I don't know if it's going to crash. All right, let's move this guy a little bit further, see what happens. Oh, lost it in its orbit. Reset it. Let's do the grid, because I think the grid will help me see what's going on. All right, let's make the sun massive. Let's move the Earth a little bit closer and see what happens. Turn off the grid. Oh, we'll turn on the path. Now it crashes. So you see, depending on the gravity and the distance away, it's going to affect how you go around it. If the sun was super, super tiny, let's reset it. Let's do path again. We'll see the gravity. We see the gravity's decreased. Let's see what's going to happen. See if it has enough gravity to stay in its orbit or not. Let's make it go faster. It doesn't. So you see how that's an important factor when we're thinking about things? If I make this guy larger, I don't think it's going to come back. But you see how we're talking about the different masses in the solar system is going to affect how things are orbiting each other. So the Earth itself also has some gravity. So it will also disrupt the space-time and we'll be able to trap some things in there. Say, for example, our moon is stuck in that orbit. So are we okay with that so far as ideas? Okay. Other things to keep in mind is some vocabulary. So when we are talking about going around an object, we call that the orbit. So that's going around an object. If we are talking about spin, we are talking about rotation. So for example, the Earth spins, the moon spins, the sun spins. When we are talking about the spin of the object, we're talking about the rotation. So orbit's going around. And then spin is talking about its rotation. Are we okay with that as ideas so far? So it's really important that we know the vocabulary. So if an object is orbiting a sun, it might be called a planet. It might not be called a planet because if it's not big enough, then we don't consider it a planet. So in order to be called a planet, you need to be orbiting the sun and you need to be large enough mass. The problem with things like Pluto is that Pluto is orbiting the sun, but its mass isn't big enough for us to consider it a planet. We consider it a dwarf planet. Remember that planets are a real arbitrary definition. It's not like a clear cut like this is a planet, this is not a planet. It's kind of like a scale of gray because we go, okay, well it meets these conditions, so we think it's probably considered a planet. Does that help? Yeah. So usually when we're thinking about things being planets, they should be spherical in shape. That's usually one of our requirements. Obviously, orbiting the sun makes it a planet. The reason why Pluto was excluded was because, one, Pluto is too small and Pluto is considered a dwarf planet. The other thing is that Pluto's moon and Pluto are sort of the same size, so that was another reason why we decided to exclude it. The next thing to keep in mind are moons. So moons are things that orbit planets. So we have a planet and you orbit the planet, you're called a moon. So I'll write that down just so we know our terminology. So when we're talking about things, we know what's going to happen. So planets orbit suns. And then moons orbit planets. And when we're talking about planets, we need them to be large enough and spherical in shape. And suns are just burning balls of gas. They are smashing together atoms and doing nuclear fission to release energy such as light. You see is the hydrogen and the hydrogen fusing together to form helium. So that's nuclear fission going on there. So that's how we classify these different objects. Questions so far? Mm-hmm. Or are we okay? Mm-hmm. We're good? Any questions? All right. So the big thing to keep in mind with this assessment is that we are looking at the relationships between these three items in our situation. So the sun, the moon, and the earth, and we're using that to explain different conditions that we see on our planet. So we need to think about how these three are interacting with each other. We also need to think about how these things are orbiting each other or rotating. Are we good? All right, let's go back to PhET real quick. So that is just the sun and the moon. If we include, the sun and the earth, let's include the moon so we can watch what's going on with that. And I think it's all reset. Let's show, I think that's all I want. Yes, path. So I love this because it's a great way to kind of see what's going on. So you see how the moon is orbiting the earth and then the earth is orbiting the sun. So it's a complex relationship that's happening there. There's going to be lots of geometry kind of related things. And we got to think about how these three are interacting with each other to result in different factors such as day and night, lunar cycles, tides, seasons, etc., etc. So that's why I wanted you guys to look at this first and have a little tinker with it. All right, are we okay with that so far? Now, obviously, this model isn't to scale. This is so that way we can actually see everything really, really easily. In reality, so you see how, actually, let me backtrack. You see how the moon is doing this kind of squiggly line around the earth? It's because when you actually have the earth and the moon together, it's doing this the whole time. But you have to remember the earth is also moving. So since the earth is also moving, that's why that is going to a three-dimensional plane now. Are we good? All right. Let's see it to scale. So this is what it's actually like to scale. So it's crazy to think that to scale, this is what's happening. So let's do gravity. Let's see, what's mass? Oh, that's pretty interesting. So there you go, the ratio between the Earth and the sun. We'll see the path. So you can't even see the moon in this case because it's so tiny. Oh, is the moon not on? Oh, thank you. There we go. So you can see basically the moon's path is overlapping the Earth's path because it's so minute in size in comparison to the scale of the universe. Are we okay so far? All right. Something else that I love to show people because I think it's crazy is the distance between our Earth and moon. You can actually fit all the planets in there. So let me show you what I mean. Distance between Earth and moon. Image with the planets. There you go. Is that a good one? That might be better. Okay, that's a better one. Okay, so something again to keep in mind with scale. So even though these objects are massive in space, what's even more massive is the space between everything. So space is a lot of empty space. It's something that you also have to keep in mind. So here's the planet Earth, and this is the moon, and this is to scale. You can actually fit all the planets side by side next to each other in that space, in that gap, which is crazy. It blew my mind the first time I saw that. So that's something to keep in mind. Even though these objects are massive, the space between them is even greater. So that's why when we're looking at these models, we often don't draw things to scale so we can actually see how things are working. So like this is drawn to scale, but in this model, we can't even see the moon. There's the moon and the planet. So again, we're really tiny actually in comparison to each other. Lots of space. And so if you think about it, all the planets can fit between these two spots, which I think is insane. Oh, this one I think is cool. So there's the satellite. I think that's supposed to be Hubble, and that's the Earth. So you see how close the satellites have to fly? So it just gives us an idea of comparison. And I wish they gave us the option to do the Earth, the satellite, and the moon, just to give you a reference point. But you can kind of get a reference point just by looking at that. Yeah? So it was crazy to think that we managed to get from here to here. What's it? Let me just pause the recording.
Okay,
Get the recording good.
the satellites constantly falling towards the Earth.
Like that. Yeah, I mean, in theory, yeah. Just 2 minutes. Wait. All right. I don't think there's anything else I want to say for that. That was just to kind of give you the foundation of information. What else did I want to say? I think I'm going to move on to the other group. Let me pause the recording because I don't think we need actually. Yeah. So I'm just playing with the planet's mass. So that's Earth. If we changed Earth to being really, really tiny, then, oops, let's reset it. So Earth is small. So now I've taken half the size of the Earth. This is our space station. And you see the space station goes away. So you can see how challenging it is for us to get stuff into space because there's a really fine line when we're trying to catch something in our gravity because you want to have enough force to get it off the planet, but not too much force that it then leaves our orbit. Does that make sense? And then it's even harder to bring something down because then again, you want to slow something down so that way it goes back onto our planet because if you, again, accelerate too much, it's going to go off. So it's a lot of math involved in this stuff. Questions from you guys? Nope. All right. Keep playing with PhET. Get some other notes. Tinker with it. Obviously, gravity is important for this. And make sure we know our vocabulary. Earth, sun, and moon. We're thinking about those three things. Planets orbit the suns. Moons orbit the planets. Make sure we're also mindful that suns are the burning balls of gas. And orbits around. Rotation or spin is going on its axis. Because you're going to have to refer to both of those things when you're writing up. Cool. All right. That's us.